All right, well, welcome everyone. This is Chris Gibbs. Today is our August Veracity SDN OT Network demo. With us today, conducting the demonstration and presentation is Jeff Smith, CTO of Veracity. And Jeff, I'm going to turn it over to you.
Sounds good. Morning, Chris. Morning, Carly. Morning, everybody on the call. So this morning we're going to talk a little bit about, and I see there's a number of folks online. We're going to talk a little bit about SDN, and if by show of hands on the call, how many folks understand what SDN is or have a basic understanding of SDN and what it is? That'll kind of give me a little bit of an idea where I should start. I see there's a number of folks on the call. And I don't know, Carly, are they able to ask questions or speak at all during the call, or?
No, I can unmute them if you would like, but just the normal is just use the chat and then I can unmute you.
Okay. All right. That sounds good.
Okay.
Yeah. So I want to get an idea, and I see we've got some different folks on the call, and somebody just joined and left. So maybe we want to wait just a minute. So we'll kind of start out with the understanding that maybe a brief discussion about SDN is necessary. A little bit of background on me, just so we kind of make it put in perspective. I was an end user for about 25 years. And so as an end user, I was responsible for all of the plant floor networks, all of the control systems, all of the PLCs, HMIs, pretty much everything in the OT space that connected from the plant floor to an IDF that is where the IT teams took over. And we went cold turkey Ethernet back in 2006. So that was kind of ahead of the curve, let's say, or on the bleeding edge. And what's interesting is if I look at what we have today as an SDN solution versus what we had then, it probably would have changed how we deployed and how we built our networks and how we managed all of the OT systems around our plants. And we had 35 sites globally and roughly 2 to 5 plants per site. So it was a sizable undertaking in 06, given that plant floor Ethernet was kind of like all the rage, and it was the new thing. So when I look at some of the things that we did, we had this whole idea of we want to connect everything. We want to go with Ethernet. But one of the things that we really didn't give a lot of consideration to at the time was the security side of it. We were more concerned with how do we treat multicast? How do we deal with multicast traffic? How do we connect everything? What kind of topology do we use? Do we use spanning tree? Do we use all these different technologies that are available that are what you would call at the time traditional IT? So there were a lot of challenges that we faced that with the advent of SDN, and in particular our Veracity SDN, the OT SDN controller, we kind of took a lot of that off the table, right? So software-defined networking has been around about 12 years now, 14 years, I guess. And it's kind of a paradigm shift in how management of a network is done. It started in the cloud space, so it was predominantly cloud. And in fact, it's majority of almost the entire cloud infrastructure is all based on software-defined networking technology. It's rolling through the enterprise space. So there's a number of people who are using it in an enterprise, and it's growing rapidly. And really, Veracity, we're the first company that's really taken a look at OT SDN or SDN for the OT space, and based on our roots, which starts on the plant floor, really applied the technology in such a way that it makes sense in the OT space. I say frequently there are probably a half a dozen gaps in the way traditional SDN works or traditional SDN works that make it difficult if you don't address those gaps to apply it in the OT space. And I think we've spent a lot of time focusing on that. And other companies who have attempted to put SDN in the OT space typically try to put a traditional SDN solution in that space. And they struggle because they don't recognize the difference between IT space and OT space. So I think that's a bit of a hurdle that we've overcome. And so what I would say is that, we're making a significant change in the way plant floor networks are done. SDN is just a way to manage the network. There is nothing different about it from the standpoint of traditional enterprise Ethernet or traditional OT Ethernet. If you have a network today, it can be an SDN network, and everything that runs on that network today runs on the SDN network. It's simply a different way to manage the network. It's a centralized approach to management versus having to run around and visit 100 switches on the plant floor and then try to manage each of those switches individually. It gives you the ability to make rules and policies that then the controller will execute for you across multiple switching platforms. So it makes it significantly easier to manage the networks. It also makes it less prone to risk. Let's face it, one of the challenges of managing a lot of switches in an environment is that you have to go to each of those switches and make the same change if you're trying to do something across the network. In this instance, you make the change once, the controller lays the change into multiple switches simultaneously. And so the amount of risk that you take making changes to the network is significantly lower. So it's the added benefit of a centralized method of approach or method of management, but at the same time, it's a lower risk and is as we all know, in manufacturing or in the OT space, mitigating risk is why we do what we do to begin with. So if you don't have a solution like our OT SDN controller, you're adding layers of risk simply managing it in a traditional way. It really simplifies the management of the network. I know a lot of our customers who are transitioning to an OT SDN network. Some of the reasons they're doing that are, they don't want to use VLANs. If you understand what a virtual local area network is, some of our customers have 10 and 15 of these in a switch configuration across a large network on the plant floor. It makes it extremely difficult for them to support and for them to manage that. And if there's downtime at all, it tends to be a big problem and tends to take longer to correct with the more complex switch configurations. Things like spanning tree, right? Rapid spanning tree or per VLAN spanning tree, which is a Cisco variant. All of those are IT methodologies or IT approaches to solving problems in a plant floor network that really don't need to be. It's a layer of complexity that we don't need. Everybody wants to segment the network, and whether it's an OT network or an IT network, segmentation is critical to security. But the VLAN or the method of doing it by a VLAN it's an outdated idea used to segment the network when you can micro-segment the network with a software-defined networking solution. You get significantly more granularity with significantly less complexity. And in the OT space, that's a huge win. I recall times in the past where electricians or maintenance folks would plug an Ethernet cable in to the same place on the same switch, right? So they go out of port 1 into port 6. And you create a loop in the network that'll cause the entire network to go down. One of the beautiful ideas behind the SDN solution is you can't create a loop in the network. The controller won't allow a loop to exist in the network that will take the network down. So it somewhat proofs itself or prevents inadvertent issues like that from happening. We talked about this a little bit, micro-segmenting. Software-defined networking in the Veracity OT controller uses a protocol called OpenFlow. OpenFlow is an open standard for software-defined networking, and it creates this idea of a flow. So if I have two endpoints on a network, point A to point B, it creates a flow between those two, and those form potentially multiple flows, but it's specific to the protocol that you're allowing. So if I allow my PLC to talk to my HMI over Ethernet IP, then I'm going to get just the necessary flows to allow that traffic. And it's a horrible analogy, but when you think of a VLAN as a virtual LAN and you use that to segment a network, think of flows as 10,000 small VLANs that are automatically managed by the controller. And that's really a bad analogy. And the more familiar you become with SDN, you understand that. But when you're kind of just getting into it a little bit or trying to understand the paradigm shift and the way your head thinks about the network, that's an easy way to think about it. It's just like each flow is its own piece of a communication between two endpoints. I think it's also important to note that with software-defined networking, it's endpoint centric, meaning I really don't care about a port on a switch, which traditional networking, you're very concerned about ports, you're very concerned about what's plugged into what port, you're very concerned about how that port is configured, and the endpoint becomes less important. The irony of that is it's actually the endpoint that you're trying to secure. So it's kind of a crossing of concepts that you're spending all this time worrying about the switch and how the switch is configured and what port is used for what and how that port is configured, when in fact it's the endpoint that matters. And if you plug that endpoint in a traditional network into a different port, then you break a lot of things and you lose a lot of security posture by doing so. In the world of SDN, that's not going to happen. It doesn't matter if the device is plugged into port 1 or port 6, the policy and the rules and the communications that are allowed applies to that device, not the port it's plugged into. So that makes a huge difference. Trying to get an idea, the SDN network is deny by default. It's the closest thing you can get to zero trust. And, zero trust is a great buzzword today that everybody uses. Zero trust means a lot of different things to a lot of different people. But at the end of the day, it means trust nothing, verify everything. And that means devices, protocols, users, pretty much anything that can interact with the network. And from the devices and network perspective, there is no other device or no other network closer to zero trust than our OT SDN controller. And that's a bigger conversation than we can have this morning. So I'm not going to really get into that, but I'd be happy to have that conversation offline and explain the reasons beyond that. So with the network being zero trust, nothing can communicate to anything. And in the example or the picture I have on the screen right now, if I want my PLC to talk to my HMI, I'm going to let the controller know that that PLC can talk to that HMI over Ethernet IP. The controller will then put the necessary flows in the switches to allow those to talk only Ethernet IP. If I were to log into that HMI and try to ping the PLC, for example, using a protocol called ICMP, that would not be allowed unless I also added a policy that said that PLC can.
Jeff, we can't hear you. Is it just me?
Like we lost your audio, Jeff.
To talk to all Rockwell
Oh, there you
HMIs. Did we lose my audio?
We lost
did
your audio. Yeah,
You're
just
back.
as you were doing the ICMP discussion.
Okay, all right. So as I was saying, you can, the ICMP wouldn't be allowed unless you also had a policy that allowed ICMP. You can create policies that are more broad scoped. I could say all PLCs in zone A can talk to all IO modules in zone B. So it can be a very finite policy that you create, or more of a broader scope policy. And it really depends on what your appetite for risk is. In my end user days, my policy probably would have been all of my Rockwell PLCs can talk to all of my Rockwell IO modules over Ethernet IP, and that would have been fine. I wouldn't have needed to be any more specific than that. Some of our customers work in the defense industry, and they are very specific, or they choose to be extremely specific in how they create rules, or power distribution, right? Utility companies. So the beauty of the controller is you really have the
you really have control over how much and to what level you want to manage on a regular basis. Nice thing about the network is it's got built-in redundancy and healing. So if, for example, that communications path is broken somehow, somebody powers down that switch in the upper left corner, somebody unplugs a cable fails, the controller will immediately calculate the next fastest path to communicate. And so it will immediately go the other route and start communicating. It's interesting that, I talked before about from a topology perspective, it really doesn't matter how you connect things. The controller is always going to pick the fastest path available to it. And in the event that path is lost, it will create another path that's, let's say, the second fastest way to communicate. So it gives you inherent redundancy and reliability. Rebalancing, we used to deploy a lot of equipment, and what we thought it would do at the supplier when it was originally built versus how much performance or throughput we'd get off the system when we started actually running product on it would vary. So they would rebalance the line. Maybe I need this set of tools down here in this station. So they would move equipment around. Well, in the traditional network, that completely destroys your security posture because everything is moving. And as I mentioned earlier, being very port specific, it's a problem if you have to unplug PLCs from a port on switch A and move it to another port on switch B, because now all of the configuration that you built into that switch for that particular device and that particular port has to get moved, or probably won't get moved, and you'll have a hole in your security posture. In the world of SDN, since I mentioned it's very device specific, it really doesn't matter. If I move that PLC, the network sees the device move, sees it show up in a different port and a different switch, and all of that policy still applies. Nothing has changed other than where it physically is connected to the network now. All the rules that govern its ability to communicate by protocol to what devices, from what devices, all of that integrity is still maintained, and it's done by the controller. You as a user don't have to worry about that. You've already said, this is what I want. The controller makes it happen. Allowed traffic. So if I've gone through and I've said, I'm going to allow this PLC to talk to that nut runner, then the switch doesn't have to communicate to the controller and ask, is this allowed? It's already allowed. So since it's already allowed, the switches do their thing and they switch traffic. They allow the traffic between those two endpoints. And the first time that communications happens, the switch will let the controller know. So you'll get a log message indicating this device has started communicating with this device over Ethernet IP. After that, you won't see messages unless something unusual occurs or some sort of anomalous behavior happens. Normally, the switch just does what switches do. And in fact, the controller can go away. You could completely disconnect the controller from the network, and those switches are going to still communicate. The network is still going to operate as you expect. You could also cycle power to the switches. When they come back up, it still communicates. Everything is still there. The configuration is sticky, just as if you had gone out and manually configured a switch. What if it's allowed traffic, but it's unknown? What if we don't know? The switch has never seen this traffic before. It has no flow or policy inherent in the switch that allows it. What's going to happen is the switch is going to send that first packet and piece of information to the controller and say, hey, this Modicon PLC is trying to talk to this nut runner over Modbus TCP. Is that allowed? The controller will look at its policies, look at its endpoints, and basically decide if that is acceptable. If it is, it writes a flow down to the switch. The switch will never then ask the controller again if those two devices can communicate over Modbus TCP. Now, if I happen to try to SSH from one to the other, which in this case you really can't, the device types prevent that, but let's assume for a minute I could. Again, that first packet of attempted communications over SSH is going to go to the controller. The controller is going to decide if it's allowed. If it is, it will write a flow down to the switch saying, let those two talk over SSH, and then it won't ask the controller again. You can explicitly block traffic. let's say, for example, you have a system that's largely Rockwell based and you're using Ethernet IP. You don't want to allow Profinet on that network. So you can create what's called a block rule or a block policy, and that will, as soon as it sees any Profinet traffic, the switch will discard that traffic on ingress. It will send a notification to the controller, hey, somebody plugged in this device on this port, trying to talk to this device on this port of maybe 5 switches away over Profinet, and that traffic has been stopped. So you'll get notification, you get visibility. Segmentation and visibility are the two things that people are really after today, right? You want to control your network, you want to know what's on your network, and you want to know what's connected to what. Our controller gives you that in nearly real time. Other solutions that are out there, some of these monitoring applications from some of the other companies, they ride on top of the network as opposed to being the network like they are with their OT/SDN controller we have. And they also can only see what the network allows them to see, and they can only see it at whatever interval you configure them to look, unless they're in line, which is a risk unto itself. So using our OT network controller, you get nearly real-time visibility and nearly real-time control of your network, and there are no other solutions in the OT space that allow that. Right, so controlling connections or protocols is a challenge. You want nearly real-time visual and rich information on your network. The network is configured the way OT people think. I want this PLC to talk to that HMI over Ethernet IP. So click the PLC, click the HMI, click allow Ethernet IP. It's literally that simple. If it takes us more than about 15 minutes to show you how to set this up and use this network, then we've done something wrong. And we have enough customers who can back up that claim and have found it to be very easy to configure. Who can access devices? That's one of the things that we don't do. We simply allow devices and control devices and protocols and flows. The beauty of the network is you can use anything you want that you're comfortable with, that you already have in place. Perhaps you have a network tool you use for access control for people and allowing access to the network. Then all of those tools still work. As I mentioned before, this is standard IEEE Ethernet network. Any tool that you currently use or have for managing higher levels than, say, just the network itself will all work just fine on this SDN solution. You can control devices and updates to devices. You can control, you can schedule, for example, maybe you want PCs to get virus definitions from, Sunday morning at 1 a.m. to 3 a.m. You can schedule policies in the controller that will allow the necessary traffic to take place during that window, but prevents it at other times. We have something called learning. So we can learn the network. So you don't have to really understand or know ahead of time what's talking to what over what. General practices, it's a good idea to have a general understanding. I know if I have a Rockwell PLC that it's talking Ethernet IP to its HMI and its IO, so I don't need to learn that. I kind of already know that. But it's amazing that with learning mode, what you will find that you didn't know was on your network. And sometimes it's important that you add policy to allow it, and sometimes it's just nice to know that it shouldn't be there and you can stop it. You can learn by network or you can learn by switch. Right. So employing SDN is like having a firewall of every port of every switch. So the firewall manufacturers of the world would love for you to put a firewall on every port of every switch. However, it's not very feasible from a management perspective. It's not feasible from a cost perspective. And so with our software-defined networking solution with the OT/SDN controller, you don't have to have that because every port of every switch acts like a firewall and gives you the ability to control ingress and egress of traffic. You can do different types of connectivity into the SDN network. There's lots of different options from that perspective. You can do remote access into the network. You can connect to brownfield and greenfield networks. There's really no limit to, how to implement this. Sometimes folks will put just a higher level aggregate switch above standard switches and networks, and that gives them east to west control between, say, zones or cells. And then they do that in a brownfield. And then the greenfield sites, they put SDN up and down the entire network chain so that they have finite control across the board. So there's really a lot of different ways to go about that. Are there any questions? Are there any questions now? This is a good time to ask before we kind of shift gears a little bit. I figure out where my mouse pointer is. Anybody have any questions they want to put in the chat? Okay. All right. Well, let's keep going. We're going to jump to a little bit of a demo now. So if you look at this network, and I'm going to open this up, and we're going to look at the controller for a minute. Wrong button. It's interesting. Where's mine? There we go. All right. So when we look at the controller, there are a number of different options to the left side here. This is a dashboard that lets you configure. And as you look, you can see some interesting statistics like which devices are communicating the most using what protocols. There is the ever popular topology display, and this is a very simple demonstration network for purposes of demo, so it's not particularly detailed. We have a programming workstation. We have a Compact Logix PLC and a Compact Logix L43. If you're familiar with Rockwell's tools, there is a package called RS Links. So this piece of software is running on this programming workstation that I'm remotely connected to. And from here, I can see both PLCs on the network. And the reason I can see that is, for example, I have this selected and this selected on the topology view, is because SIP is an allowed protocol, and SIP is the same as Ethernet IP. So I've allowed those. I've also allowed ping. So if I were to open up a command window, for example, and I were to ping one of those PLCs, and I have a policy that allows that, I should be able to say ping 192.168.201.26, and I'll just have it run the ping continuously. So ping is allowed. Well, what if I were to say it's not allowed? What if, for example, I were to come over here and say, I'm going to control traffic. I'm going to select these guys. Actually, let's do it this way. Let's jump over here to the policy page, and you can see this list of policies. Just to make it very easy to do this, I'm just going to delete this rule. That way I don't have to go, oh, well, let me turn off learning mode. That's a great demo too. Actually, we'll just get rid of all these. When I do that, I could have also done that through the UI by selecting this and this, right? And do control traffic. I could have gone to this, which is a traffic control page, which allows me to make larger changes to the network, right? And then if I come back over here, let's do two things. Let's look at RS links. Since I removed that policy or rule that allowed SIP or Ethernet IP, those can't see, my programming workstation can't see those two devices anymore. And since I removed the rule that allowed ping, we can see that I also can't ping it anymore. So let's go back here. We'll select this guy. Who am I pinging again? 2.6. So we're going to select this guy. We'll select this guy. Shows me the path taken to get there. I can control traffic. And if you'll notice, you see SIP none, ICMP none. That means that I'm seeing the traffic, but I'm not allowing the traffic. So if I were to allow the traffic and apply that rule or policy, it's going to show here in a minute, it's going to show allow. If I go back to my list of rules, we're going to see that the controller created this rule for me. And then more importantly, if I come back here, we're going to see that I can ping again. I'm now allowing those two devices to talk, right? So that gives me the ability to control that traffic. You'll notice, however, I still can't see them from RS links. The SIP or Ethernet IP traffic is not allowed. I could create a rule that says this guy can see this guy, and I'll come in here and say over SIP. So when I do that, I've basically said these two guys can talk with Ethernet IP. These two guys still can't. So when I go back to RS links and I force it to refresh, we're going to see that I can see and browse and do whatever I want with the one I've allowed. But since I have no policy that allows the other one, it's not seeing it. It's literally not on the network as far as it's concerned. Now, if I want to get a little crazy, I can go to learning mode and I can say, okay, show me everything that's on the network. And if I go look at my list of policy, I'm going to see policies come in here as things are learned. So if I come back to links and I force it to refresh, links, RS links tends to take its own time. We're going to see things start showing up. So there's the other PLC has shown up. We've seen other traffic on the network. So we've learned this traffic based on what is actually on the network. So I can actually see this stuff taking place. So IGMP snooping. So IGMP is turned on this programming workstation. There's some general UDP traffic on that. And if I take it back out of learn mode, it won't learn any new rules, but now I have probably full visibility to both of these devices. And I could, now the real question is, looking at this list, can I ping the other PLC? So let's go look. So the L43, we know we can ping because that's what we're doing right here, 26. But what about 27? Can I ping 27? The short answer is going to be no, I can't, because that traffic was not on the network when I had the system in learn mode. So it doesn't allow it since it didn't learn that traffic. Now, if I were to put the network back in learning mode, now the controller and switch sees that traffic happening. So it's going to learn that traffic and it's going to write a policy right there that allows that to work. Now, earlier I mentioned you can be very generic with policies. So in this case, I've got policy that says, allow ICMP, which is ping, from the programming workstation to the compact logics. I have another one up here that says allow ping from this compact logics to this programming workstation. Well, I could just create a single policy myself, right? So now my pinging should have stopped. Yeah, I can create a single policy that says allow proto ICMP. Oops, learn how to type. ICMP on any. When I do that, I have a single policy that says ping is okay. Whatever wants to ping can ping. Don't care. So now this is working. If I stop it, and I go back and I start it, it's allowed to happen. Because I've got this singular policy that's a bit more broad stroked, saying anything on my network can ping anything on my network. And that works pretty much with anything. If I get rid of this and this, I'll get rid of these two SIP rules, right? And when I get rid of those SIP rules, they're going to lose connectivity through RS links from my programming workstation. But I could create a rule that says allow proto SIP on any. I can create it that way. I can also come over here and I can say device, zone, or type. So I could say any one of my devices. I could say any one of my types or any one of my zones. So let's create a zone. Uh-oh, my browser might have just locked up on me. Let's see. Let's create a, let's expand this. We'll go to zone management. We're going to create a zone called PLCs. Right, we'll save it. We're going to create a zone called programming workstations, and we'll save it. I'm going to go put those devices in one of those zones. So my programming workstation is a part of zone programming workstation. We'll save that. My compact logics L16 is also going to be a part of PLCs. Right, we'll save that. And my L43. Now the other way I can do this is by multiple selections, and I can pick what zones they belong to here. So now I've got these in these zones, and I can go back to my traffic control, and I can say allow zone programming workstations to talk to zone PLCs over Ethernet IP, and I'm going to allow save. I can put a whole bunch of changes in here, hit review, and then apply them. When I apply them, we're going to see a rule created right here called allow SIP on zone programming workstation to zone PLCs. And when I do that, and I refresh here, I can talk to those because this guy is now in a zone, and he's allowed to talk to this guy and this guy, who are also both in zones. So as you can see, it gives you very finite control of the network. You can decide the level of detail or the level of the policy that you want to enforce. There's change set control. There's a northbound API, which is very powerful. It lets you interact with the controller from higher level systems and applications. You get a device list of all of your devices. So backup options that exist, there's a question in chat. The backup options are you can completely back up and export the controller and save it. In the very near future, there's going to be a scheduled backup to a known network location. IP spoofing, there's nothing in this network that prevents IP spoofing because you can't really prevent IP spoofing because there's nothing to an IP address other than it shows up in a table in the network. MAC spoofing is an actual thing. And with the controller, it fingerprints the device so that it pulls. So in the case of a Rockwell PLC, for example, we can pull the serial number, the firmware revision, the product codes. So there's a number of pieces of information we get that are all part of the fingerprint of that device. And so when we see that device on the network, we validate it against that known, quote unquote, stuff that we've learned. And so we can prevent that from happening. Not all devices are smart enough to provide that. I mean, if you have older OT devices, sometimes they just don't have the smarts to provide the necessary information. So there's a certain level at which you can and can't get that data to fingerprint it. So, Luis, I see you asked some questions, and Chris Gibbs will answer your questions in chat. Chris is the sales guy, and he can help you with that. We do have partners in Spain and Europe and all over the globe that can help you. So I will let him answer that question. Other than that, Carly, I think I've run through the controller and its capabilities and kind of demoed it a little bit.
Okay.
So if there are other questions folks have, or Luis, if you have additional questions or anyone else, happy to answer them. So I don't know if we just want to sit and wait for any more questions or how you normally wrap these up, Carly.
Yeah, normally just if anybody has any questions here at the end, and if not, we go ahead and wrap up. And then alternatively, like for example, this conversation between Chris and Luis, you could follow up offline to just share contact information and set up something else so that it doesn't so that we can end the call if we want. But yeah, otherwise we just close it up for this month. And if anybody has any additional questions, feel free to reach out.
All right, that sounds great. I think we probably are good on the question front. I appreciate everyone joining the call today. Hopefully you get kind of a quick look at what we had. Obviously, there's a lot of capability here and a lot of power and potential. I could expound on this for hours and show you just all sorts of cool stuff, and we'd be happy to do that if you're interested in a deeper dive demo, or you want to talk with a larger audience, perhaps from your organization. Reach out to Chris, or make a note in chat, and Chris can reach out to you, and we'd be happy to set that conversation up.